Welcome, and thank you for joining us today for Enterprise Strategies for Hybrid Multi-Cloud Networks. My name is Raleigh Gould, and I'll be moderating today's event. Our featured speaker is Shamus McGillicuddy, VP of Research covering Network Infrastructure and Operations at EMA. Shamus has nearly 2 decades of experience in the IT industry. His research focuses on all aspects of managing enterprise networks, including network automation, AIOps-driven network operations, multi-cloud networking, and WAN transformation. And before I hand things over to Shamus, I wanted the audience to know that Shamus will be concluding his presentation today by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email with the on-demand playback, as well as additional information about this new research. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thanks, Raleigh, and thank you for everyone for joining us today for this webinar on hybrid multi-cloud networking strategy. And I apologize in advance if you hear any noises in the background. One of my cats is crying about not getting any attention from me at the moment, and I'd lock him out of my room in my office, but then my Wi-Fi signal would cut out. Anyway, I want to thank the sponsors of this research. This is independent market research that I conduct and pretty much completely control and is made financially interested in the data that I collect to understand the market, and also, they get to promote themselves like right here. So thank you to these 5 companies that financially supported this research. We have Blue Cat, Efficient IP, and Infoblocks, who are all vendors best known as providers of DNS, DHCP, and IP address management. IBM is obviously a technology multinational with a lot of interests in the world. They'd have network observability solutions, network automation solutions, multi-cloud networking solutions. And then NetScout is a network monitoring and network performance management vendor and cybersecurity vendor offering a variety of especially packet-based intelligence and analytics around performance, compliance, and security. So thank you to those 5 companies. Research methodology. This research is based on a survey of 354 cloud networking stakeholders in hybrid multi-cloud enterprises. So we asked them to tell us how many cloud providers they use. Anyone that was using 0 or 1 was kicked out of the survey. And by cloud provider, I mean they had to tell us they were using multiple infrastructure as a service or platform as a service providers. We weren't interested in people that are using multiple SaaS providers, right? We weren't interested in people who were using AWS and using Microsoft Office or Outlook service providers. And they also had to continue to maintain private data center infrastructure. They had to either have on-premises data centers in operation and or some kind of co-location footprint or hosted private cloud provider or something that was providing private data center infrastructure. So that's how we defined a hybrid multi-cloud enterprise. And you see, you've been staring at this chart for a minute or two. This just shows you the demographics. There's subject matter experts or executives, variety of silos within a technology organization, and it was a transatlantic survey of North America and Europe. So the reason why I did this survey was one of the reasons why was in recent years in my ongoing research into enterprise networking. You've seen indications that companies that maintain hybrid multi-cloud environments tend to struggle with network operations, like they're having problems designing, building, and operating those networks. And I saw some, there's a variety of different factors that come up in analysis of our market research data that can give us multiple reasons for why that's happening. But I wanted to do a deep dive into it with this research. the first thing I wanted to understand was just like who's driving the car or the bus. And if you surveyed companies 10 or 15 years ago about who was running the cloud, they would have probably said like lines of business or the CEO or COO. They were adopting the cloud because they wanted to get the IT organization out of the way. And that's no longer really the dominant um, uh, profile in the cloud these days. And I've watched this evolution closely, like lessons learned over time, like letting lines of business lead some aspect of digital services, digital infrastructure is problematic because you take the experts that know how to build resilient, high performing, and secure infrastructure out of the equation and leads to disaster. Like classic example, a few years back, just talking to a network architect at a Fortune 500 retailer who told me that like he was brought in as a consulting expert for a cloud team that had no infrastructure experience, who was migrating their e-commerce platform into the public cloud, and he was there to tell them how to do PCI DSS compliance, and then he left and went and started working on another project. And then he gets 6 months later, disaster. Can't launch the new e-commerce app because we're not PCI compliant. Can you come look at it? And he goes and he looks, and they ignored everything he told them to do. So that's what I'm talking about. So you see here, only 13% of the companies survey told us that a line of business was driving cloud strategy in some way. This is based on a multiple choice question, by the way. Like they were able to select like 2 or 3 organizations most responsible for driving strategy. So only 13% selected line of business. And those companies tended to also tell us that their cloud networks were failing. Instead, cloud leadership was most likely to be coming from 3 areas: the IT executive suite, where the CIO and his direct reports and directors and VPs live, the cybersecurity or IT security organization, and the IT infrastructure and operations team. So these are the people who probably traditionally drive IT strategy 10, 15 years ago, who were sidelined in a lot of enterprises by the initial migration into the cloud. Only 21% of companies told us they still have silos formed when lines of business were driving things. Instead, 37% say they've established some kind of center of excellence that bridges those silos, like pulling experts from different groups, having some sort of team that's really focused on making sure that they're building guardrails and things, silos altogether. And that was really prevalent with, so it seems that when cybersecurity's got control, like they really try to dissolve the silos that formed up over the years between IT and cloud. So another thing we wanted to ask before we got into the networks that we explored in this research was, why are you multi-cloud? The top 5 responses to technical initiatives that push them into using multiple cloud providers are on the left. You see operational technology or Internet of Things. So they have a lot of industrial devices, operational technology out in the field. They want the applications that drive those or analyze those devices to be closer, perhaps reduce latency for like real-time automation and stuff like that. That's a big driver now. Majority of them said that's something that pushes them into multiple clouds. Number 2, AI. No surprise there. That's the most overhyped thing I've ever seen in my lifetime is AI. So of course everyone's thinking about that. Data center offload and cloud first strategy is another initiative that affects about half of them. Like, going to deploy a new app, it should go in the cloud. really want to reduce our data center footprint as much as possible so that we have less CapEx, more OpEx. Let's do that. Let's push it into this cloud provider that's really good for this particular type of application that we want to deploy. And then DevOps and CI/CD practices. So that just tells you that if like they're really focused on empowering DevOps, that's pushing them into multiple cloud providers. Because often like DevOps don't really they they're really focused on like the platforms the cloud providers use and how they can best utilize them for the types of applications they want. They don't really think about the infrastructure layer as much. And so like they'll come to the network team and the security team and be like, hey, we've decided we need y'all. We're going to do the second cloud provider, or we've decided that we want to do AI, and our preferred cloud provider is not really providing the tools we want to use. So we're going to go into the second cloud provider. And then infrastructure team's like, okay, let's try to build it for you. And then last, hyper automation, just automating all aspects of digital infrastructure as much as possible, seems to be pushing people in the cloud, because cloud providers and cloud tool stacks tend to have some really good automation options that aren't always as robust when you look at the on-prem infrastructure, especially in the networking world. Network infrastructure is notoriously a difficult area of automation. I'm actually doing research right now on why it's so hard. And then on the right, you see business factors that drive people to select multiple cloud providers. It's all kind of self-evident. Like, oh, we want to be more flexible and scalable. We want to optimize costs by going to lowest cost provider in this region or whatever. We want to optimize end user experience by deploying as many clouds as possible as close to our various distributed workforces. We need to accelerate innovation, and what better way to do that than adopt this newest capability from this provider that just knocked on my door. Compliance and data sovereignty. Obviously, we're going into Latvia. We need that cloud provider that's in Latvia. Examples. So that's the cloud strategy world. What's happening at the networking layer? Well, cloud networking remains challenging. Only 25% of the people that we surveyed told us that they're completely successful with implementing and managing their hybrid multi-cloud networks. So that's not great. 3 out of 4 see room for improvement. The top 4 technical pain points that they're feeling in the cloud networking space, in the layer, the networking layer, is performance issues, cloud, and this gets back to what I was saying about like taking the IT people out of the equation in the early days of the cloud. A lot of cloud teams that were mostly developers didn't really know how to architect a network in a way that it would deliver like a high perform. Like they knew how to build applications that performed in terms of like software architecture, but they didn't know how. They didn't really think about like how the networks they set up in and around the cloud environment would impact performance. And so you'd get a lot of rollouts of applications that had lots of problems with performance, especially when the number of users of that application ramped up. So yeah, performance issues persist as a problem. Cloud networking product maturity. So like people are adopting cloud network infrastructure and services from individual cloud providers or from networking infrastructure vendors or startups that are delivering tools and products and software that are designed to help build out and manage cloud networks. And those products are still maturing. They might not have as many features as you want. They may have some stability issues. They may not be supported in every cloud provider you want to use. And then network address issues was a big one. That came in third. So, IP address overlaps, DNS complexity, symptoms of cloud teams not working effectively with the network team on managing that stuff. We see a lot of fractured IP address management and DNS management in the cloud, in the multi-cloud world. And then inconsistent capabilities across cloud and on-prem. So like you have tools that you're using in the cloud space, and you have tools you're using in the data center network, and you may be trying to extend like your data center overlay, network overlay that's based on like VXLAN or whatever into the cloud, and you see mixed results with that. And like the cloud team's like, I just want to use the the tools that the cloud provider has delivered. Like I don't care about how you do subnetting in the data center. It's it's not what I want to get in. And it just leads to increased complexity. So another thing that we see is that cloud providers dominate as a provider of solutions for hybrid multi-cloud networks, which should immediately be a red flag to you. 62% of the respondents in this survey said that cloud service providers are critical suppliers of our cloud networking solutions, like firewalls, routers, load balancing, DNS, whatever. And 61% said we use cloud provider solutions for cloud network observability. So, you know, is that going to deliver you the same level of visibility as the tools that you've traditionally used to monitor and manage your on-premise networks? Probably not. Not from what I've seen. So that is, it's not surprising, but it is frustrating that people are still, if they're going multi-cloud and hybrid multi-cloud, that means that they're using proprietary networking technology stacks in each of those environments. One stack for AWS, one for Azure, one for Google, one for whatever. On the right, you see like the response to the question, what are the things you find most challenging when you're using the native network functions and services that your cloud providers offer? Number one, cost. When you go from like a subscription to annual subscription for like a firewall to like paying hourly for something or daily for something, the cost can add up. Limited network security solutions, like, hey, like I'm trying to have my entire network security stack native to my individual cloud providers, but they don't really offer a featured next generation firewall, or I don't really love DDoS protection. They have problems with connecting cloud to on-prem resources. Like maybe they're instead of doing like a direct connection between their data center and their cloud for all cloud connectivity, they're probably trying to like connect a lot of their remote sites and offices directly to the cloud, and that's adding complexity. Um, Inconsistent networking features across clouds, like that gets in. I kind of mentioned that already in the context of inconsistency between on-prem and cloud networking. But yeah, when you have, you might find like, oh, well, you know, AWS offers this, which is really good for, you know, how I approach load balancing, but Azure doesn't have a comparable offering. Like they offer something that works to some extent, but it's really hard to have consistency there. Fragmented management, like you're swivel chairing all the time if you're trying to have an end-to-end approach to cloud networking operations. And then a lack of advanced networking features and issues around compliance, telemetry, like at least 1 in 5 are having issues with all this, including skills gaps, which is the least problematic thing, but it's still an issue for 1 in 5 companies. So how do you build better hybrid multi-cloud networks? First thing you got to do is reduce management complexity. And successful organizations in our research told us that they are prioritizing integrated management of networks across clouds. So here you see this question: to what extent is it a priority to manage each of the following in a centralized and unified manner across all your cloud providers, cloud regions, and data centers? And you see only one of these where it's more likely to be a low priority than a high priority, and that's subnets and VLANs at the bottom, which made sense because, like as I said, like people that are managing VPCs in the cloud do not want to manage subnets and VLANs in the same way the data center network does. Yeah, so network security policies and controls is the highest priority to centralize management of, and that makes a lot of sense, like because that's going to reduce your risk significantly if you can have a consistent approach to security policy across all of your digital infrastructure. It makes sense, and I don't know why people are taking a fragmented, siloed approach to it. I wouldn't, I would, that would be like the first thing I do is like, why do you have like 8 different approaches to network security policy? Like it's not, it doesn't make any sense. IP address space, like I talk to people over and over again. They're like, yeah, I use an enterprise IPAM solution to manage all my IP address space. And I'm like, oh yeah, how do you handle cloud? I'm like, well, the cloud team does their own thing. And what happens then? Well, then like we see IP overlaps that cause connectivity issues and performance. Yeah, we're having issues where like there's overlaps between what we do in the data center and what we do in the cloud, and it's a problem. Okay, then maybe you should extend that. Well, I just can't get buy-in. Cloud ingress and egress controls, also one of the biggest priorities. That's also pretty a huge like security risk issue. And also it can be a cost issue as well. Like you want to centralize that so you can optimize egress costs, you know? Um, and then secondary priorities are DNS services because, man, I can't tell you, like I'll talk to network engineers who are just excited that they can discover all the DNS that they have in the cloud, let alone control. Like, oh yeah, look at this. I have this tool that discovered like 20, 30 different DNS services across my clouds. This is so helpful. Now I'm going to reach out to the owners of all of this and try to have a conversation with them. It's like, okay, good luck with that. And then load balancing, traffic routing are also pretty high priorities. So yeah, people who told us that they're making these high priority tended to report higher success with cloud networking, especially network security policies, IP address space, load balancing, traffic routing. Those were big best practices. Establish an effective source of truth about your cloud networks. Now, this is an area of debate. When I talk to people about network source of truth, they have different opinions on what that means. We defined it in the survey as like a system that captures all network related data and makes it available to cloud network teams for operations. Like, here's all the data you need to make a change. Here's all the data you need to like figure out a path on your network or like what ports are available or whatever. And it doesn't have to be like one central system that like has everything in it, right? And I don't think anyone really does that. They have like federation or they have something that syncs with different systems of record, which I'll get into in a second. But basically, what we found is that organizations that told us they had a comprehensive approach to a network source of truth for their cloud environments were twice as likely to be successful with cloud networks, as opposed to people who are like, well, we can get most of operational data about the network into something that's accessible. Those guys were not doing great. And then like people who were like, yeah, everything's kind of incomplete. Like there's stuff that we just can't get um, right easily. Those people were just crashing and burning. So how do you get an effective source of truth? Well, the people that were most effective with their source of truth told us that they had adopted some sort of central platform that syncs with other systems of record. So and that syncing can be two-way, like, oh, well, I pull information from directly from the network, or I pull information from like this network change and configuration management tool, and then I push information to our CMDB because that thing's terrible at discovering infrastructure, and like it's always got bad data. Those people are doing the best with their network source of truth. People who told us they had a federated system where various systems of record are exchanging data, and you go to various systems and you can see like different types of information in each system, and it's still pretty well automated and accessible. Those people are doing okay with their network source of truth. And then the 10% of people told us that they had siloed systems that are often referenced manually. They had a terrible source of truth and were struggling with their cloud networks. And just to get you a sense of like what's involved in a source of truth, this probably isn't any surprise, but people told us that 61% said, hey, data center infrastructure management's a piece that's got like our inventory and might have some configs in it, and it actually might have some IP address space in it. 49% said they were using IPAM tools, IP address management tools. 53% said they were using a network controller involved. A network controller was involved in some way. That might be like an SD-WAN controller or an SDN controller in your data center, or it might be a controller if you still have one of those, or maybe like a cloud-based controller that's like Jing switching, things like that. And then 47% said a CMDB, a configuration management database, was involved. Number 3 thing that you need to do is improve cloud network observability. Only 29% of the people we surveyed told us they are completely satisfied with their ability to observe their cloud networks with the tools that they have on hand. 61% said that they were using observability tools from their cloud providers, which I referenced in an earlier slide. Those people reported less overall satisfaction with their cloud network observability. Their ability to monitor, troubleshoot, and optimize their networks was less effective. 57% said they were using 57% said they're using a traditional network performance management or network observability tool. Those terms can be interchangeable. I'm not going to go into the definitions here, but they reported more success with their overall network observability tool set. And then 51% said they are using a network infrastructure vendor's tools, like, for instance, a SD-WAN vendor has native observability on it, maybe a data center networking vendor that they've extended into the cloud to some extent, extended the overlay of that vendor in the cloud, or maybe a multi-cloud networking specialist. All of those have native monitoring to some extent. Those people tended to be neutral on their feelings of how effective their tooling was. But clearly, from what you can see there, those numbers don't add up to 100% because people are using multiple things to get visibility. We asked them, like, what are you focusing on? Like, what are you monitoring closely, or getting, where do you need good reporting and dashboards? Nearly half said we really need cloud interconnect visibility, which tells you that they are doing a lot of multi-cloud applications, or maybe even that might be like because they're tracking like synchronization of data as they're running a DR environment in a second cloud provider. And they want to make sure that that synchronization doesn't impact performance. So it's got to be happening at the right time of day or night. Then 5% said data center to cloud interconnects. That one they've probably had as a priority for a very long time, because that's one of the first things that the network engineering team was really responsible for managing, was like those interconnects between their data center and the cloud. And then site to cloud. So that gets into the complexity I mentioned earlier about like connecting the cloud to the on-prem network, and like it's no longer exclusively through this interconnect that 45% of people here are focusing on. They're connecting a lot of their remote sites, branches, campus and office buildings and industrial sites directly into the cloud, and that adds complexity, and they need to keep an eye on it with observability. On the right-hand side, you see a spotlight on some key data sources that were admittedly of interest to some of the sponsors of this research. Packet monitoring, like I talked to someone just a couple months ago who said he had invested in a leading real-time network performance management vendor for real-time packet monitoring of his AWS environment. It was like the first time he was investing in real-time packet monitoring, and it was to monitor their cloud, not his data center. And actually, he was using it for both NDR and performance monitoring, which are the two top use cases for packet monitoring in the cloud. He wanted to track security, network detection and response, and he also wanted to monitor performance in his cloud. 49% said also want to do troubleshooting, which goes hand in hand with performance monitoring, and then compliance was a pretty prominent use case for packet monitoring as well. And then you see DNS traffic analysis. I'm increasingly seeing people thinking about DNS for for cybersecurity reasons, like tracking, looking for malicious behavior. Threat detection was a number one use case for it here in their cloud network observability, but also performance monitoring. Like DNS can impact performance if it's not built and managed properly, but it also can give you indicators of performance trouble in some instances. Other best practices that my research uncovered: do not rely on the internet for on-prem to cloud interconnects. People told us that they're using internet connectivity, probably, obviously probably with a VPN on it, to do interconnect as opposed to like peering or some sort of like direct connection interconnect, a co-location facility or direct connection offered by a cloud provider. Those people badly. The performance just was not acceptable. People who told us that they emphasize service resiliency in their multi-cloud networking design were doing well. So that's something that's kind of self, but I just wanted to highlight it. Focusing on the partnerships between the networking team and the cloud team is important. And people who told us that they really want to make the cloud and networking team work together on these 5 things: security policy management, integrations, automation, security incident response, network troubleshooting, and infrastructure deployment, not necessarily in that order. Those were areas where if they're focusing on bringing people together on that, better with their cloud networks. And then finally, recognize the strategic value of private data centers. Not everything belongs in the cloud. I think a lot of people recognize that these days, that not everything should go in the cloud. And people that reported successful cloud networks, like they told us that they plan to leverage private infrastructure in the long term. Other people said that they were planning to reduce their data center footprints, either partially or completely in the long term, and they were having more problems with the cloud networks. So I think there's something there. I couldn't tease it out completely from the data, but I really do think that like there are certain things that just are challenging to migrate to the cloud, and it has a trickle down effect to how the cloud network operates. So the full report dives into a lot of other stuff and explores some of the stuff I've already talked about in more detail. If you want to learn more about how people are doing IP address management and DNS in the cloud, I asked a bunch of questions about network automation that I didn't even really touch on here at all. There's more about their approach to network observability. There's an exploration about like what kind of application connectivity is happening between clouds and between clouds and data centers, and also more information about the infrastructure solutions and architectural choices people are making in their hybrid multi-cloud networks. So you can download that with this bit.ly link here. And with that, I'm going to turn it over to Raleigh for Q&A.
Thanks, Shamus. Diving into the questions, the first one is, aside from cloud providers, what other solution providers are they using in these multi-cloud networks?
So more than half are using a data center networking solution. So I think that's them extending their data center network overlays, like VXLAN overlays or something, into the cloud to have sort of like a hybrid cloud environment. So they can have some sort of uniformity in how they do VLANs and subnets and like have some layer 2 connectivity across those environments. 47% said they're using some kind of multi-cloud networking solution, and I define that as either an overlay, like overlay software, or some sort of API-driven network orchestration that sort of creates some sort of uniformity into how they configure, manage, and operate cloud networking technology across multiple cloud providers, so that they can have that consistency of management from AWS to Azure and the networking stacks, even if they're using native networking solutions of those cloud providers. Almost 40% said they're using a DNS, DHCP, and IP address management vendor, and 36% say they're using software-defined interconnection services to sort of build out their cloud backbone. And 32% said they had incorporated an SD-WAN vendor into the cloud network, or a secure access service edge provider, which really gets into the need to connect like corporate sites directly into the cloud in a secure and effective manner. So that's an overview of what we saw.
Thanks, Shamus. How does a CMDB differ from a network source of truth?
Well, CMDB is not usually owned by the networking and network engineering team, so it's not. Um, I mean, I'm not an expert on CMDBs. I only know as much as what network engineers tell me because it's not really something I focus on. But it's usually like a tool that has like configuration information about like the entire IT infrastructure, right? And it has and it's usually not in a format that the network engineering team wants. It's usually not directly controlled or accessible by the network engineering team in a lot of ways. Usually has poor discovery capabilities around the networking layer of things. And it's usually, I think it's like an issue of like who owns it and who controls it and like what the quality of data is within it. So a network source of truth is usually a tool that the networking team controls, and it's something they chose. Really popular open source tools out there right now, but there are also like a lot of people using, as I mentioned, DCIM tools, DDI tools like IPAM, or a combination thereof. And it's usually got information besides configuration management. I mean, besides configuration data in it, like it's also going to have like IP address space. It's going to have security policies. It's going to have some inventory information that you might not see in CMDB. So it's more fit for a purpose of network operations.
Thanks for that explanation, Shamus. The next question is, did you explore whether these companies are experiencing any tangible benefits from having a cloud network source of truth?
Probably. I don't, I think I did ask that question, but I don't have the data in the top of my mind right now. So I will point you to the report to answer that question. Sorry. Oh, you know what? I know that one of the top responses to that question was reduced security risk. I know that. I remember seeing that in the data.
Thanks, Shamus. That brings us to the conclusion of today's event. As I mentioned at the top of the hour, I will be sending out a follow-up email that will include the on-demand playback as well as additional information. So be sure to check that email out. Thank you again for taking time out of your schedule to join us, and I hope we'll see you at a future EMA research webinar.